Hey guys, so today we're going to talk about the phases of the moon. So let's get started. The first thing I want you to know is how the phases of the moon work. What causes the phases of the moon? And there are two things. The first thing is the Earth's rotation. As the Earth rotates, we're experiencing daylight on one side, on the side facing the sun, and then nighttime on the other side. And the moon's phases are normally mostly visible during the daytime. And when it's nighttime for us, we're there. The moon's phases are still there. We're just seeing the darker versions of the phases. And we'll talk more about that in a bit. Now, the moon's revolution also plays a big part because as the moon revolves, different parts of the moon are being lit up by the sun, at least from our point of view. We're seeing different angles of the moon being lit up by the sun, and that causes the moon to appear to have different phases. Now, another thing you need to know is that the moon's orbit is actually elliptical. It has a slightly oval orbit around the Earth. Sometimes it's closer to the Earth, and sometimes it's farther from the Earth. When it's closer to the Earth, it has a higher gravitational pull by the Earth, so it moves slightly faster. And when it's farther from the Earth, it has less gravitational pull, so it's actually slightly slower. Now, we actually always see the same side of the moon. We from Earth at least, you can't see the other side of the moon. And this is interesting, and the reason for this is because the moon's period of rotation, the time it takes for the moon to rotate, the moon actually rotates, is equal to the period of revolution, the time it takes for the moon to go around the Earth. And that's 27.3 days. This is something you need to memorize. So the moon's period of rotation is actually 27.3 days, and the moon's period of revolution is also 27.3 days. Let me show you how this works. So, in this simulation, this is the Earth, this is the moon, and this is the sun. The binoculars show you the observer, how we're viewing the moon. And this flag is showing you which part of the moon we're looking at. So if I play the simulation, notice that as the moon is revolving around the Earth, we're seeing different phases of the moon, and we'll explain this a little later. But for now, we're noticing that no matter what, as the moon is revolving around the Earth, we're always seeing this flag side of the moon, this one side of the moon, and we're not really seeing the other side of the moon at all. And let me show you why and see. Let's see. Um, as the moon is revolving, we're still seeing this red part or red flag, and here's why. Notice that this is one full revolution of the moon. It takes about 27.5 days. Um, but notice that the moon also makes one full rotation at the same exact time it makes one full revolution. Notice this flag. This flag is to the left side of the moon, right? Now it's in the to the bottom of the moon from our perspective right now. And now it's to the right side of the moon, and now it's back to the top of the moon. It made one full rotation at the same exact time as one full revolution around the Earth. And because of this equal motion between the moon's revolution and rotation, we are always seeing the same exact side of the moon. Okay, and it takes about 27.3 days. So, period of rotation, the moon's period of rotation is equal to the moon's period of revolution, which is about 27.3 days. Make sure you have your note packet out and let's write this down. The Earth's moon, for the Earth's moon, its period of rotation and period of revolution are both 27.3 days, and they are the same. So, that's why we always see the same side of the moon. Now, let's talk about the moon's phases. Even though the moon makes one full revolution in 27.3 days, the moon actually takes about a little more, 29.5 days to make one full cycle. Let's see why. Well, here's the moon. Like we're looking at this flag. It makes one full revolution back to the same spot in about, let's say, yeah, around 27.3 days. Okay, but notice that it needs to go a little farther to be between the sun and the earth again. And this is complex and it's not very clearly shown in the simulation, but yeah, yes, the moon revolves around the Earth, but remember, as the moon is making a full revolution around the Earth is also moving around the sun, right? And that's why, even though the moon makes one full revolution around the Earth has already moved a little bit since by the time that has happened, when by the time the moon returns to its original position. And since the Earth moved around the sun a little bit, it's not in the same exact position anymore by the time the moon gets back. The moon actually has to travel a bit further to reach the sun again, be between the sun and the earth again. So that's why, even though the moon makes one full revolution around the earth in about 27.3 days, since the earth also is moving at the same time, the moon has to travel a bit farther to make to be between the sun and the moon again to complete a full set of phases. So, since we're talking about the phases, let's see what the phases are like. The first phase that we're going to talk about is when the moon is between the sun and the earth. Notice that half of the moon is lit up and half of the moon is in darkness. The lit up part of the moon is right next to the sun or facing the sun. The darker part of the moon is where we are from on earth, on our side. And this is because from our viewpoint on Earth, even though half of the moon is lit up, the part of the moon that's lit up is on the other side, right? The side facing the sun. And remember, we only see one side of the moon. So to us, the moon looks completely dark. And we call this the new moon, when the moon looks completely dark. But notice as the moon is revolving around the earth, now we're starting to see a little bit of light to the right side of the moon from our point of view. The moon is still only half lit up by the sun, and half of it is in darkness. But remember, we're still seeing the same exact side of the moon, this flag part. And as the moon is revolving, we're seeing different angles of the moon and how the sunlight hits the moon. So from our point of view, we're seeing most of the moon being dark and a little sliver of light to the right side, and that's why the moon looks like this in the sky. And then the moon keeps revolving, and notice that we're seeing more and more of the moon being lit up on the right side. And when the moon reaches this point, we're seeing from our point of view, we're seeing the left side of the moon being dark in darkness and the right side of the moon being lit up. The lit up part is facing the sun. And now the moon keeps on revolving around the sun. And notice in this point, we are seeing most of the moon being lit up and only a little bit in darkness to the left side. Although remember, half of the moon is still lit up and half of the moon is still in darkness. This is just our perspective as the moon is revolving around the earth. And now, when the moon is on this side, on the opposite side of the sun, we call this a full moon. The entire moon looks lit up because we're now facing the moon side of the moon that is fully lit up by the sun. The sunlight is completely shining on the side of the moon that we can see. But notice, as the moon keeps on revolving, now it's starting to get darker on the right side for us because we're seeing a different perspective. So, from our point of view, we see mostly light, but a sliver of darkness on the right side of the moon. And then as the moon keeps on revolving, now we're seeing the right side completely dark, or half the right side is dark and half of it to the left side is light. This is not the same as when the moon was over here. Notice that when it was over here, for us, from our perspective, the right side was dark, half of the right side was dark, and half of the left side was half of the right side was lit up and half of the left side was in darkness. But now, when the moon is over here, from our perspective, we see half of the right side is in darkness and half of the left side is lit up. And as the moon continues to move around the earth, now for us, from our perspective, we see most of it is in darkness and a sliver of light to the left side. And finally, when the moon finally comes back to its position, we're back to a new moon. We're no longer seeing the light side of the earth moon that is lit up. That part is facing the sun, and we are only seeing the dark part of the moon, the dark side of the moon, and we call it the new moon. And this takes approximately 29 days, about a month, for all the phases for the moon to go through all of its phases. And remember, this is not the same as the moon making a full revolution around the earth. A full revolution takes 27.3 days, and the moon needs to travel a bit further to go through a full phase, because the phases of the moon require the sun. And for the moon to go around the earth and back to the same position between the sun and the earth, it needs a couple extra days because the earth is also moving around the sun. So one thing you need to also memorize is that a full cycle of the moon is about 29.5 days, about a month. It takes about a month for the moon to make a full cycle from new moon back to new moon. And that means a half a cycle takes about 15 days, about 2 weeks. Okay, remember this. Let's write this down. A cycle of phases for the moon, for a complete cycle, it takes 29.5 days. And for half a cycle, it takes about 15 days for the moon to make a half a cycle of phases. Now, let's talk about when what we call the different phases of the moon. You have to know two different words: waxing and waning. Waxing is when the moon appears to be getting brighter and bigger in the sky, and waning is when the moon appears to be getting darker and smaller in the sky. And these are our phases. Notice that when the new moon is always next to the sunlight. This is when we are seeing the darker part of the moon, right? And we're calling it waxing when the moon is getting bigger or appearing to be getting bigger. We're seeing more and more of the lighter part of the moon until it reaches the full moon. And then waning means the moon is getting smaller and smaller. So that's when the moon appears to be getting starting darker and darker from the right side of the moon until it reaches the new moon. So let me show you this in the simulation again. So this is the new moon. It's completely dark, and we call this part phase of the moon the waxing crescent because now we're seeing the moon, or the moon appears to be getting bigger or brighter, starting from the right side. And now half of the moon is more bright, or the moon is half bright to the right side. We call this the first quarter. And then over here, the moon is mostly lit up. We call this a waxing gibbous, gibbous because of the shape. And waxing, once again, means that it's appearing to be getting bigger and brighter until it reaches the full moon. The whole moon is lit up. Now, remember, waning means the moon is getting darker or smaller, right? So now notice that this is the waning gibbous, meaning gibbous because of the shape of what the moon looks like, and waning because it's getting darker on the right side, or looking to be, it looks like it's getting smaller. Now over here, this is the third quarter. This is called the third quarter. Half of the moon is in darkness on the right side. And now this is the waning crescent. We're creating a crescent shape, and it's waning because the moon appears to be getting smaller. And then finally we have the new moon. The moon is in complete darkness. Now, you don't have to memorize the different names of the phases, but you do need to know what each of the phase looks like and in which position. And for that, you need to a memory trick might help you. A waxing moon, meaning a moon that is starting to get lit up, will always get lit up on the right side. So when you're looking up at the sky and you see the right side of the moon is lit up, you will know that the moon is starting to wax or starting to appear to be brighter or bigger, or we're going from a new moon phase to a full moon phase, because that's when the moon is lighter on the right side. So it gets a little bit of light on the right side, half light on the right side, mostly light on the right side, and then full moon. Now, for a waxing moon, the right side is dark. When you look up at the sky and you see that the right side of the moon is dark, you should know that the moon is starting to move from a full moon to a new moon. It's going to keep getting darker. So that's why from a full moon, it starts to get dark on the right side a little bit, and then half dark on the right side, and then mostly dark on the right side, and then fully dark new moon. So waxing is when the moon appears to be getting brighter and bigger and brighter on the right side, or the light is on the right side. And then waning is when the darkness is on the right side. Let's write this down. The two types of phases are waxing and waning. Waxing is when the right side of the moon is lighting up, and waning is when the right side of the moon is getting darker. Now, how would you draw the moon's phases? How do you even remember all this? Well, start with where the sun and the earth is. If I see a diagram like this, and the sunlight is coming from the left, and here I have the earth, and the moon is supposed to go in the counterclockwise direction around the earth, the first thing you need to do is figure out where the new moon is and where the full moon is. Remember, the new moon will always be right next to the sunlight, because when the moon is right next to the sun, we're seeing the darker part of the moon because the moon is actually blocking all the sunlight from reaching the earth. We're just seeing the dark side. So that's why we call it a new moon. And the full moon will always be opposite the side of the sun, because if the moon is on the opposite side, then we can actually see the part of the moon that is being lit up by the sun. So that's the first thing you should do, is determine that the new moon is right next to the sunlight, the full moon is the opposite. And next, it's pretty simple. From the full moon to the new moon, we're going counterclockwise, right? From the full moon to the moon will start to get darker on the right side. If the full moon is completely lit up, we know that the full moon has to get darker to become a new moon, and it's going to get darker on the right side. So over here, it's going to get a little dark to the right side, and then over here, it's going to get half dark to the right side. Over here, it's going to get mostly dark to the right side, and then we have the new moon. Now we made a whole half of the moon's phases. What about the other half? Well, from if we want to go from new moon to full moon, then the moon has to go from dark to light, right? And when the moon gets lighter to become a full moon, it also gets lighter on the right side. And that's exactly what you're going to do. So after the moon gets slightly light on the right side, and then half lit on the right side, and then mostly lit on the right side until it's fully lit in the full moon. And that is how you have all your moon's phases. Now, you might be given pictures of the sunlight coming from different directions, and as always, you need to draw the full moon and the new moon first or determine where they are. Remember, the new moon will always be right next to the sun, and then the full moon will be on the opposite side of the sun. And then from the new moon to the full moon, the moon will get lighter on the right side, a little bit light, half light, mostly light, and then fully light. And then from the full moon to the new moon, it's going to get darker on the right side. So slightly dark on the right side, half dark on the right side, mostly dark on the right side until you get a new moon. But the new moon will always be right next to the sunlight in the diagram. And that's it. Go ahead and try the questions.